Okay, so let's get started. Hello, everybody. My name's Kavir Hay, and I'm your resident-friendly neighborhood solutions architect from AWS. Today, I'm going to talk about VPC Lattice and AWS PrivateLink, and a new service offering that AWS has with cross VPC resource access. In the talk, I'm going to cover a few different items, mainly how to utilize VPC resource access, but also a few different architectural patterns. Over the talk, it may sound like I'm repeating myself, but the idea is to reinforce some of the concepts and just showcase a few different patterns that we can then utilize. And to close it off, we'll give a real-world example of how to utilize cross VPC resource access services. So if we look at a typical pattern connecting today, what do we start off with? We have a front-end service, we have a back-end service, and then we have some sort of database connectivity. And we know that most of these services connect on layer 4. They need some sort of high bandwidth capability between the back-end and the database. And as AWS, what different types of offerings do we have as services that we can use to connect up these different services? So if we think of today, we've got two offerings. We've got AWS Transit Gateway, which can scale up to 5,000 VPCs. We've got Amazon VPC peering, which allows you to be able to connect up to 125 different VPC peers. You can scale up across region. It's extremely fast, lower latency. But then you've got the capabilities of Transit Gateway, which gives you the flexibility to be able to implement different types of typologies, whether it be hub and spoke, a centralized model to be able to do things like VPC inspection. And with those capabilities, how would we address the patterns that we talked about? So you could use AWS Transit Gateway and the front end connecting the front end application to the back end, and you can use VPC peering to provide that high bandwidth capability to connect up to the database. But as networks evolved, we always know the question of security comes into place. And how do we think about that, right? With AWS, you have all these logical constructs in the cloud, but how do you have the flexibility to be able to think about security groups, NACLs, AWS native firewall services. But the considerations that come with that add complexity. So what we try to do with the capabilities that we're providing is how do we provide simplicity? How do we provide the capability to be able to link security groups across transit gateways, across VPCs, across accounts, and simplify that capability? And for any of those of us who've been in networking for a very, very long time, we think about requirements. So we've all been there. Your boss comes in, he goes, we need to connect up to a AWS partner. We need to provide some connectivity into this architecture. We've onboarded this new service from a third party. How do we go about doing that? How do we provide flexibility to be able to connect into this partner? And how do we do it at a low cost? So if we think of our pattern, we've got VPC4 at the top here. And what we need to do is provide some sort of connectivity. So we go to our resident solutions, AWS solutions architect, and we say, what do you have within the what does AWS have from a connectivity standpoint to be able to provide this type of connectivity? And that's where AWS PrivateLink comes in. So if you think about what AWS PrivateLink gives you, it gives you a pattern for VPC to VPC connectivity. It supports 100 gigs worth of scalable throughput. We can connect using TCP, and we've added the additional capability now to connect using UDP. We support this over multiple accounts, and it gives you the simplified benefit of agnostic, or what we call overlapping IP addresses. So in the producer and the consumer account, you can have the same IP address. And because it's inherently built on a unidirectional flow, it provides for a more stateful and managed connectivity pattern, right? So how do we do this, and what do we do? We go back to our team and say, with that, we can provide some VPC endpoints, a secure way for the front end to be able to connect into the third party via a load balancer, providing the third party with the ability to be able to connect up into their service, scale their services independently of how we connect to those services, allowing them to do things like blue-green patterns, do deployment structures, without having to involve engagement every single time. So it gives you a lot of flexibility around that. And then we evolve over time with this. Boss comes back in, he goes, well, I've just been to this famous DevOps conference. We want to modernize. We want to be able to support Lambdas. We want to be able to support containers. I heard all of this at an AWS summit, and I want to be able to put in these. So again, they come back, we look at our architecture, and we've realized actually we've built a reasonably good pattern. We've provided an AWS Transit Gateway, we've provided VPC peering, and if we swap those EC2 instances out with these different capabilities, you still have the ability to be able to modernize your compute without having to change much in the architecture. But as time moves on, with all of these new capabilities, because now we can support Lambdas, containers, and we want to be able to modernize the architecture, we want to move towards a microservices pattern. So we want to be able to add new services. We want to be able to provide new capabilities for our customers to try out. And with that, we have an additional requirement to add a new VPC as we add new services from the different teams. So once again, we go back to the drawing board. We say, what do we have from AWS that can provide some sort of capability to simplify this architecture? And that's where AWS VPC Lattice comes in. VPC Lattice is a VPC to VPC connectivity point. It provides you with the ability to still use agnostic IP addresses, but it also gives you flexibility to be able to do things like blue-green testing with weighted connections. You can do path-based selection to be able to route traffic as it's required. And with that, we also provide the ability to be able to do more granular security, so you can control who has access, how they have access, and honor some of the security practices the security requirements that come through the organization. So what we do, we add a VPC Lattice service network into the architecture. We provide link local access from those containers in a secure manner. So what that does is, if you think of any of the services, whether it's a container, an EC2 instance, or a Lambda function, from the ENIs, they can access natively into the VPC Lattice network to then access those the backend services or the databases that sit behind them. But time evolves, new requirements come, and the business is starting to grow. We think we need to say, add a few more resources. So we've got a new AWS, we've got a new partner that resides on AWS. We want to be able to grow that infrastructure. And the requirements are to be able to provide a slightly more flexible architecture in this pattern. So we go back, we look at our architectural diagram and go, what do we actually need to be able to provide connectivity today? And previously it was a simple service like an EC2 instance, but now we actually want access to a database because the data architecture is evolving. We need to be able to provide connectivity to these data to be able to provide to these databases. But these databases change. They have different types of flexibility. You need to be able to scale them up, scale them down, and how do you provide a connectivity in a reliable manner? And that's where AWS's new capability of cross VPC resource access comes in. So what we've done is give you the flexibility of different ways to be a consumer. So you can use the best of both technologies using AWS native PrivateLink, but also to be able to use AWS Lattice, VPC Lattice network. So with this new capability, you have the ability to be able to connect to different types of resources. You get the benefits of utilizing benefits of both VPC Lattice and VPC PrivateLink, which you can use both at the same time. You also get a security first concept because you have the ability to be able to define a resource policy, define the configurations within that, within how those resources are then exposed by the service owner. And we've introduced the concept of a resource gateway. So if we go back to our architecture and we think, how would we go about this? What we then introduce is a resource gateway and a resource configuration. And with that, we've introduced this new concept from a consumer point, is a VPC resource endpoint that you can now connect to. And this is all great, but that architecture diagram is starting to look fairly complex. Management come back and say, how can we simplify all of this? We've got all of these new types of capability. We've got private links. We've got VPC Lattice. Can we simplify the architecture? So once again, we go back and we look at our architecture and we go, well, could we do away with a transit gateway? Could we do away with a VPC peering? And if we utilized VPC resource access, could we build a different architectural pattern and simplify this architecture? And the answer is absolutely yes. You can now simplify the architecture and reduce the cost depending on the access pattern using VPC Lattice. So how would we go about that? We create new resource configurations. We place resource gateways in certain access points, and we create a full service mesh exposing the services. So that's all great in concept and architecture, but how do we actually implement this? And how does it actually break down to be able to utilize the VPC resources? So we've got the concept of a VPC consumer, and we've got the concept of a VPC resource. What are the different types of VPC resources that we have available to us? We can use VPC EC2 instances. We can connect to clusters. We can also connect through to different databases. And one of the flexibilities that VPC resource affords us is that we actually can also connect up to the on-prem environment. So if we wanted to be able to grab some of those benefits, what we've done with this is give you the benefits of using native AWS services that you're already comfortable with. So things like AWS Resource Access Manager, the benefit to be able to scale and use the service that's best purpose fit for the pattern that you'd like to utilize, being AWS VPC PrivateLink or VPC Lattice, and then providing connectivity back to the on-premise environment as well. So that's all good, but how do we actually get started up with this? So the first thing we need to do is create a VPC resource gateway, and I'll touch a little bit later on what that actually is. But once we've done that, we need to actually define a policy for what is the service that we actually want to expose, which is a specific type of resource. We've covered the different types. Once we've configured those resources, we can now use Resource Access Manager to be able to share those with all the different consumer accounts. And what is a resource gateway? A resource gateway is simply an elastic network interface that we place within your VPC that allows us to connect to different resources that you'd like to expose as the producer or the resource owner. This supports the scales across multiple AZs. You don't have to manage it. The idea behind it is as you scale the number of services that you want or resources that you want to expose, the ENIs then scale accordingly. So you get the benefits of of AWS doing the undifferentiated heavy lifting of scaling those ENIs without you having to focus on any of those things. But what are the different types of resource configurations that you can actually access in your resource configuration policy? So today we support three different types. We support IP addresses, so you can connect using IPv4 and IPv6. We support domain names, and we support AWS ARNs specifically for RDS databases. But what does that actually give you? So if you wanted to be able to utilize a group of services or something like a Redis cache cluster, what you have the ability to do is we also support child configuration. So what you can place within the cluster is configure multiple different child resources, group them into a parent resource, and then share the parent resource across different consumer accounts. This simplifies the connectivity pattern. It simplifies how you would connect. And the same is available for AWS databases using an ARN. And we'll talk about what some of the benefits are for using an ARN over just using the traditional either DNS or IP-based capabilities. So from a consumer point, we have a few different ways to be able to connect through to these new resource gateway services that we exposed. One of those is using a new VPC endpoint called the service network. What the service network gives us is the ability to be able to have a rooted endpoint within the VPC that multiple different services connect to. So we also have a VPC association, and what this is a linked local connectivity pattern. So what happens is for all the different EC2 instances, you would connect in only from that VPC. It's a more secure pattern, it's more lightweight, and if you don't need to be able to scale, if you need to be able to just isolate it into a specific VPC, this provides a simple and clean connectivity pattern for customers. Sorry for that. So once again, with AWS, it's about giving customers choice. The idea is that you can either connect using a VPC resource endpoint, or you can utilize a VPC service network, or if you need a more isolated and secure pattern, you can then utilize the VPC service network association. But if we were to look at these and knowing when to use which use case, VPC resource endpoints are great for a connectivity pattern where you just want to connect to one or two, to one service, or just expose a specific service. But as you start to scale that out and you want to be able to offer a more rich offering, let's say you're an ISV or want to be able to provide a more SaaS solution that is made up of multiple different components, be it a database, be it a Kubernetes cluster with some EC2, then how you expose those services, leveraging things like a service network, simplify the connectivity pattern. You create the VPC service network endpoint once. Customers can then connect to that service endpoint, but they're able to connect to multiple services behind it, simplifying the connectivity pattern for customers. So just iterating it. Again, within that, we've got the service network endpoints, or we've got an aggregate with the service network associations that utilize linked local IP addressing to be able to provide the connectivity. These are some use cases or configuration patterns that we typically see with ISV customers who expose services. So if you think of things like connectivity patterns like Databricks, Snowflake, or Confluent Cloud, they are now looking at utilizing these connectivity patterns to be able to connect customers to resources within their environments. We also have traditional ISV vendors who have services that reside on-prem. So one of the benefits of having an AWS resource gateway is that ISVs can actually provide connectivity patterns to services that either reside on-premise or in other data centers, and they provide secure connectivity back to those services and still expose those to customers using AWS native services. From a cost consideration perspective, one of the best things to consider is resource endpoints are significantly cheaper, more cost effective from a cost perspective because it's $0.2 per an hour. Service networks, because you can scale multiple services within a specific resource endpoint, come at $0.1 per an hour. And then you are charged for the data processing costs associated for the data that's transferred through that. We also have a few other patterns that we provide. So if you need to be able to do some orchestration and be able to connect to services in a secure manner, you can connect consumer services using AWS step functions with Event Bridge that can then call a service through a resource configuration as well. So that gives you a more event-driven architecture for how you would build those specific patterns. That's all good. We've covered the few patterns. We've covered how the different resources work. But how do we put all of this together, and how does it kind of benefit the customer? How do you bring the benefits of both AWS PrivateLink and Lattice together? What we know is about using these AWS native primitives to be able to give resource owners the flexibility in how they'd like to expose the services. So whether it's EC2, Lambda, connecting it with AWS step functions, or if it's an event bridge-driven architecture, you have the flexibility to be able to expose it as a resource owner in a simplified manner, which is purpose-fit. And I'll cover what the connectivity patterns and what the best use cases are shortly. And from a consumer side, you have the ability to be able to combine all of these architectures. So whether you're using a resource endpoint with a service network, you have the ability to utilize both those patterns together. So if we think about the consumer connectivity, a VPC resource endpoint is great for one-to-one connectivity, for simplified deployments. And if you're not really sure on what the connectivity pattern and you just need connectivity to a service, a resource endpoint is purpose-fit for that. If you want a reusable pattern that you want to be able to connect to many VPCs, but you don't want to expose those services outside of that VPC, using non-routable link local IP addresses in VPC Lattice is the perfect use case for using a VPC Lattice association, and is the preferred choice for service networks on AWS. When it comes for scale patterns that need to go cross-region, on-prem, through transit gateways, and scale across a multitude of different AWS services, that's where I'd recommend using an AWS VPC network service endpoint, as it gives customers the flexibility to scale the environment to meet those needs. If we dive deep into how does this actually work, on the consumer side, in the VPC, we have a VPC endpoint that's made up of multiple different ENIs, and what we provide the customer with is a DNS record for the Lattice service. So in your VPC, you get a VPC endpoint DNS IP address that you can then use to connect to the service. The benefit of this and how you would go about setting this up. So as the resource owner, there's only 3 steps involved. You create the resource gateway, you create the resource configuration, and you share it using Resource Access Manager. As the consumer, it's a simple pattern of, I've been shared this resource, I accept the resource, and then utilize that DNS that DNS alias that's been provided to you. The connectivity pattern is simple because you're using an AWS type resource configuration, but if you need the more complex patterns using VPC association or VPC service network, you have the option to use that using VPC endpoints as well. So what we do within your subnet as a consumer, that VPC endpoint points to an ENI that's taken out of your subnet. So as the consumer, you set up your subnet, you attach this VPC, the resource ENI into your VPC. And how that aligns to be able to be consumed is that we have in the AWS substrate compute that we can scale to be able to provide this connectivity. And on the producer side, we also have the ability to be able to scale the resource gateway as and when the resource gets consumed by different consumers. So we simplifies the pattern. Again, we have so what are good use cases for the resource gateway? Resource gateways can connect out to different services. You can connect out to services that reside on the internet. You can connect via the transit gateway back to on-prem, or you can connect to services within a VPC. In the opposite direction, from the on-premise environment, whether you want to connect using AWS Direct Connect Gateway or from a VPC, as a consumer, you have the option to be able to connect to services within AWS. So we provide different connectivity endpoints. The one thing I would call out is with this particular pattern, you can't use it using using an internet pattern. For those for connectivity via the internet, it's better to use an AWS network load balancer or application load balancer as a pattern for internet-facing connectivities. When it comes to these the types of resources that we supported, as I previously mentioned, you can connect to AWS RDS databases. You can connect via DNS, or you can configure a set of resource groups. With Amazon RDS databases, we support all the different types of database, being DB2, SQL Server, MariaDB, MySQL, Postgres. But what is the benefit of using an AWS ARN instead of just configuring the IP addresses or utilizing the DNS name? One of the benefits of AWS databases is that we can provide you with database writer endpoints and reader endpoints. With that, every time you need to do maintenance or you need to go through upgrade cycles, you need to fail over a cluster, the benefit of utilizing the ARN is that AWS does all of the heavy lifting for you. So as the DNS changes in the resource owner account, we also update the resource endpoint in the consumer VPC, so you don't have to worry about all of that undifferentiated heavy lifting for the databases. So you configure the DNS ARN, and we do fully managed DNS for you. This simplifies it. But what if you want to use your own domain? So we've got lots of customers who want to be able to utilize their own DNS. Again, with AWS resource configuration and AWS private hosted zones, we have the ability to be able to allow for aliases. So you can then alias your internal domain to point to the VPC Lattice CNAME, and from there you've got simplified connectivity back. These are some resources. I hope you found that interesting. Again, there's a QR code for access to AWS PrivateLink, access to the different VPC lattice patterns that I've talked about today, and a blog that Jeff Pass posted. Just to call out, we've got our AWS Skills Center in Cape Town, which we've talked about, and we've got the AWS Skills Builder, which you can sign up for a free account today. Thank you, everybody. Please take the time to fill out the survey in the app. I hope that's been extremely useful. Thank you very much.